Hi guys! In this video, we're gonna discuss the different types of plate boundary. But before we start, Mr. Ines will introduce who's Alfred Wegener.
Alfred Wegener. In full, Alfred Lothar Wegener. Born November 1, 1880, Berlin, Germany. Died November 1930, Greenland. German meteorologist and geophysicist who formulated the first complete statement of the continental drift hypothesis. The son of an orphanage director, Wegener earned a PhD degree in astronomy from the University of Berlin in 1905. He had meanwhile become interested in paleoclimatology, and in 1906 to 1908, he took part in an expedition to Greenland to study polar air circulation. He made 3 more expeditions to Greenland in 1912 to 1913, 1929, and 1930. He taught meteorology at Marburg and Hamburg and was a professor of meteorology and geophysics at the University of Graz from 1924 to 1930. He died during his last expedition to Greenland in 1930.
Now you know who Alfred Wegener. So let's go and talk about what are the different types of plate boundaries. Mr. Esmeralda and Miss Bobogol will explain it. Enjoy!
There are 4 types of plate boundaries. Divergent boundaries, where new crust is generated as the plates pull away from each other. Convergent boundaries, where crust is destroyed as one plate dives under another. Transform boundaries, where crust is neither produced nor destroyed as the plates slide horizontally past each other. Plate boundary zones, broad belts in which boundaries are not well defined and the effects of plate interaction are unclear.
Scientists now have a fairly good understanding of how the plates move and how such movement relate to earthquake activity. Most movement occurs along narrow zone between plates where the result of plate tectonic forces are most evident.
Now you know what are the different types of plate boundaries. So let's explain them one by one. Miss Ofenda and Miss Suarez will explain the convergent boundary.
Convergent boundaries. The size of the Earth has not changed significantly during the past 600 million years, and very likely not since shortly after its formation 4 billion years ago. The Earth's unchanging size implies that the crust must be destroyed at about the same rate as if it is being created, as Harry has surmised. Such destruction of crust is placed along convergent boundaries where plates are moving toward each other and sometimes one plate sinks under another. The location where sinking of a plate occurs is called subduction zone. The type of convergence, called by some a new very slow collision that takes place between plates, depends on the kind of lithosphere involved. Convergence can occur between an oceanic and a largely continental plates, or between 2 largely oceanic plates, or between 2 largely continental plates. Oceanic to continental convergence, if by magic we could pull a plug and drain the Pacific Ocean, we would see a most amazing sight, a number of long, narrow, curving trenches, thousands of kilometers long, 10 to 10 kilometer deep, cutting into the ocean floor. Trenches are the deepest parts of the ocean floor and are created by the subduction of the coast of South America along the Peru to Chile Trench. the oceanic Nazca Plate is pushing into and being subducted under the continental part of the South American. In turn, the overriding South American plate is being lifted up, creating the towering Andes Mountains, the backbone of the continent. Strong distracted earthquakes and the rapid uplift of mountain ranges are common in this region, even though the Nazca Plate as a whole is sinking smoothly and continuously into the track. The deepest part of the subducting plate breaks into smaller pieces that become locked in place for long periods of time,
before suddenly moving to generate large earthquakes. Such earthquakes are often accompanied by uplift of the land by as such as few meters. On 9 June 1994, a magnitude 8.3 earthquake struck about 32 km northeast of La Paz, Bolivia at a depth of 636 km. This earthquake within the subduction zone between the Nazca South American plate was one of the deepest and largest subduction earthquakes recorded in South America. Fortunately, even though this powerful earthquake was felt as far away as Minnesota and Toronto, Canada, it caused on major damage because of its great depth. Oceanic to continental convergence also sustains many of Earth's active volcanoes, such as those in the Andes and the Cascade Range in the Pacific Northwest. The repetitive activity is clearly associated with subduction, but scientists vigorously debate the possible source of magma. Magma is generated by the partial melting of the subducted ocean slab or the overlying continental lithosphere, or both. Oceanic to oceanic convergence. As with oceanic to continental convergence, when two oceanic plates converge, one is usually subducted under the other, and in the process a trench is formed, the Marianas Trench paralleling the Mariana Islands. For example, marks where the fast-moving Pacific Plate converges against the slower-moving Philippine Plate. The Challenger Deep at the southern end of the Marianas Trench plunges deeper into the Earth's interior, nearly 11,000 meters. The North Mount Everest, the world's tallest mountain, rises above sea level about 8,854 meters.
Now you know what convergent boundary. Let's move on and let's discuss the divergent boundary. Mr. Panulte and Miss Azul will discuss the divergent boundary.
Divergent boundaries. Divergent boundaries occur along spreading centers where plates are moving apart and new crust is created by magma pushing up from the mantle. Picture two giant conveyor belts facing each other but slowly moving in opposite direction as they transform newly formed oceanic crust away from the ridge crest. Perhaps the best known of the divergent boundaries is the Mid-Atlantic Ridge. This submerged mountain range, which extends from the Arctic Ocean to beyond the southern tip of Africa, is but one segment of the global mid-ocean ridge system that encircles the Earth. The rate of spreading along the Mid-Atlantic Ridge average about 2.5 cm per year or 25 km in a million years. This rate may seem slow by human standards, but because this process has been going on for millions of years, it has resulted in plate movements of thousands of kilometers. Seafloor spreading over the past 100 to 200 million years has caused the Atlantic Ocean to grow from a tiny inlet of water between the continents of Europe, Africa, and the Americas into the vast ocean that exists today. The volcanic country of Iceland, which straddles the mid-Atlantic ridge, offers scientists a natural laboratory for studying on land, the process also occurring along the submerged parts of a spreading ridge. Iceland is the splitting along the spreading center between the North American and Eurasian plates as North America moves westward relative to Eurasia. Map showing the mid-Atlantic ridge splitting Iceland and separating the North American and Eurasian plates. The map also shows Reykjavik, the capital of Iceland, the Thingvellir area, and the location of some Iceland active volcanoes, including Krafla. The consequences of plate movement are easy to see around Krafla volcano. In the northeastern part of Iceland, here existing ground cracks have widened and new ones appear every few months. From 1975 to 1984, numerous episodes of rifting took place along the Krafla fissure zone.
Some of these rifting events were accompanied by volcanic activity. The ground would gradually rise 1 to 2 meters before abruptly dropping, signaling an impending eruption. Between 1975 and 1984, the displacements caused by rifting total about 7 meters. In East Africa, spreading processes have already torn Saudi Arabia away from the rest of the African continent, forming the Red Sea. The actively splitting African plate and the Arabian plate meet in what geologists call a triple junction, where the Red Sea meets the Gulf of Aden. A new spreading center may be developing under Africa along the East African Rift Zone. When the continental crust stretches beyond its limits, tension cracks begin to appear on the Earth's surface. Magma rises and squeezes through the widening cracks, sometimes to erupt and form volcanoes. The rising magma, whether or not it erupts, puts more pressure on the crust to produce additional fractures and ultimately the rift zone. East Africa may be the site of the Earth's next major ocean. Plate interaction in the region provides scientists an opportunity to study firsthand how the Atlantic may have begun to form about 200 million years ago. Geologists believe that if spreading continues, the three plates that meet at the edge of the present-day African continent will separate completely, allowing the Indian Ocean to flood the area and making the easternmost corner of Africa, the Horn of Africa, a large island.
Now you know the two types of plate boundaries. Let's go to the last type of plate boundaries, the transform boundary. Miss Alerta and Miss Mausay will discuss the transform boundary. Let's go.
Transform boundaries. The zone between two plates sliding horizontally past one another is called transform fault boundary. The concept of transform fault originated with Canadian JP6J. Tuzon Wilson, who proposed that these large faults or fracture zones connect two spreading centers, divergent plate boundaries, or less commonly trenches. Convergent plate boundaries. Most transform faults are found on the ocean floor. They commonly offset the active spreading ridges, producing zigzag plate margins, and are generally defined by shallow earthquakes. However, a few occur on land. For example, the San Andreas Fault zone in California. This transform fault connects the East Pacific Rise, a divergent boundary to the south, with the South Georgia, Juan de Fuca, Explorer Ridge another divergent boundary to the north.
The Blanco, Mendocino, Murray, and Malacca fracture zones are some of the many fracture zones that scars the ocean floor and offset ridges. The San Andreas is one of the few transform faults exposed to the land. The San Andreas Fault Zone, which is about 1,300 km long and in places tens of kilometers wide, slices through two-thirds of the length of California. Along it, the Pacific Plate has been grinding horizontally past the North American Plate for 10 million years. At an average rate of about 5 cm, land on the west side of the fault zone is moving in northwesterly direction relative to the land on the east side of the fault zone.